Hi.
You're like, don't do it. I'm Karin Wolok. I lead the developer community at StarTree.
I am Tim Berglund. I run the developer relations team at StarTree. We're a company that makes a cloud service based on Apache Pinot, and that's kind of what we're going to talk about today.
Yeah.
Right? So, yeah, Karin and I are going to talk to you about real-time analytics and Apache Pinot and Apache Kafka and kind of the way all these things relate. And Karin, why don't you kick us off?
Sure.
I'm going to wander around the stage while you talk.
Yeah, I'm trying to just figure out, like, do we have to stand in this area to, like...
If you want to be seen, so I'm looking at this, you have to be right here.
All right, well...
Right behind the podium,
I mean, you guys
can
still see me, right?
Yeah.
Okay. So thank you guys all for coming. I'm going to start off and just kind of give you guys a little bit of background, just like fundamental of what is... I don't know if it's me or you. What is real-time analytics? Oh, it's him. Blame that guy. Don't blame us. Just like everything's so sensitive here. So we'll talk to you a little bit about what is real-time analytics and user-facing analytics and things like that. So I'll just kick it off, give you some fundamentals. So generally speaking, there are three types of analytics. The first one is dashboards and BI tools. This is probably the most commonly known popular one. This is usually used for internal purposes, like BI analysts and things like that are usually kind of assessing this data. It's dashboards, right? I think most of us are pretty familiar with analytics dashboards. The next one is user-facing analytics. This is my LinkedIn. If any of you guys want to be my friend, feel free to join. So the user-facing analytics is a little bit, it's not that it's newer, I think it's newly kind of categorized. So what user-facing analytics is that when you're building products and providing analytics to your end users or your consumers, right? So it can be things like in this, in some cases, it's like who viewed your profile. Sometimes you have graphs and things like that, and you can slice and dice it. Or it could be things like news feeds and stuff like that. I'm going to kind of get into something else around user-facing analytics in a little bit, but it's basically when you're providing analytics to the end users of your products. And then the third one is machine learning. This is usually when a system is the one who's doing the processing at the end on the BI analytics kind of side, right? So this could be like automated fraud detection or anomaly detection, things like that. But basically a machine is on the opposite side doing some kind of analysis. Either that system has the ability to trigger some actions if something happens, or there's a human behind it that it then alerts, and then the human has to, assess it and things like that. So those are, in general, the three types of analytics, generally speaking. So we're going to go in a little bit first into user-facing analytics, into this specific presentation, and the one that I was mentioning. Now, why do you care? I don't know. I'm guessing you guys kind of care. You're here. So user-facing analytics has actually transformed businesses, right? So there are companies and organizations that have actually productized the ability to give their end users analytics and access into real-time insights. So they've created specific products or premium features and things like that that are surrounding the real-time analytics for the end users. This is kind of like how it's transcended over time. It started from internal operators, analysts, and then users and customers. And then it's just full business transformation. There's literally companies that are focused on strictly bringing analytics to their end users, right? So there is definitely some value there. The other thing, or like what a lot of organizations are doing, is not just offering analytics to your end users as you would see normally, like your dashboards and things like that, but actually creating actionable insights. I think this is something that's pretty important to take away from this presentation in general, because when we speak of real-time analytics, a lot of times we kind of just assume dashboards and BI tools, like the normal analytics stuff. But with actionable insights, what that actually does is it offers your end users the ability to take action when they have real-time insights. So for example, you have some fraud detection things set up, or they're pulling in real-time data. They need to know when something happens. They need to be able to push a button or take some kind of action based on those real-time insights that they get. And kind of going back to that LinkedIn thing that I was showing before, like, things like a news feed, people click on something, they comment, whatever. Those are actually all actionable insights where you're basically feeding your users real-time data or real-time analytics, and they have the ability to take action on it. So that's what actionable insights is. What's my next slide? I don't even know. Okay, so I'm going to go over some general use cases of where this is seen in the real world. So I'm going to start off with LinkedIn because LinkedIn has they have really productized their real-time analytics for their end users. So who viewed my profile is a really good example of one, right? So every time a user goes into who viewed my profile feature, basically they're pulling in all this fresh data and they're able to see who viewed their profile. Then they're able to slice and dice it by all these different dimensions like company or location and things like that. Which in LinkedIn's use case, it's actually quite complex because of all the different dimensions that they have. And I mean, they have, actually, this is wrong. I think they have over 800 million users now. And there's, hundreds of thousands of queries per second at some points. And then there's a lot of dimensions on this data, and for the users to be able to look into kind of a slice and diced view, it's quite complex. So this is an example of one who viewed my profile at LinkedIn. Another example is the news feed, which I kind of shared before. So what happens is every time a user goes to the home page, you want to make sure that they're seeing information that is new and relevant and something that they haven't seen before, right? So you have to be able to take all these things into account when you're showing them their feed. And ultimately, what do you want your user to do? You want them to take some kind of action, right? So this is where like the actionable insights really comes into play. It's also in play in the who viewed my profile where they can connect or message or look at the other person's profile and things like that. Ultimately, what that does is that increases your end users' satisfaction, the consumer engagement and things like that. So that's another example of kind of like where the real-time analytics transforms into actionable insights. Another example that they productize this is your talent insights that they offer all the recruiters that are using LinkedIn, right? This is constantly fresh data that they're offering to these recruiters, and part of it is the power that the recruiters have in their hand by taking action on those things. If they see some trends or whatever have you. So these are like 3 examples at LinkedIn where they're productizing real-time analytics. Another example of real-time user-facing analytics is the Uber Eats use case. So Uber developed Uber Eats as like a restaurant manager, so it gives access to a lot of restaurant owners to be able to get a bird's eye view of all the things that is happening inside of their organization. So like you could see here, this is a screenshot from their platform. So you can see missed orders, inaccurate orders, top selling items, feedback, things like that. Now, if an item is, you're getting bad feedback, you need to know right away, right? If delivery times are delayed or something like that, you need to know when it happens. You can't know in an hour or the next day or something like that. So it's really important that this is real time for the end users. And again, this is like quite complex because there's a lot of dimensionality and things like that. But when Uber Eats is giving this capability to their end users, then they can take action when there's any kind of thing that they see that needs to be addressed. Could be good or bad. So that's the Uber Eats use case. Another use case that's real-time analytics, this is personally one of my favorites. I don't know why, I just like this one, is the Stripe use case. So Stripe's use case is a little bit complex too, in terms of what they're doing with real-time analytics. This is user-facing analytics, but it's more on the internal side, so I'll explain. So obviously, if you guys don't know, it's a financial payments company, right? So they deal with a lot of regulations and a lot of very sensitive financial data. It obviously has to be very accurate. You can't screw this up, right? Not like you should be screwing up anything, right? Even like LinkedIn, who viewed my profile, you see somebody who like viewed your profile who didn't.
It's like Karin never viewed my profile. Why does it say Karin viewed my profile?
Or if you thought I did and I actually didn't, that's even worse.
That would be like potentially weird. But you're right. It's lower stakes. It's social media. It feels like lower stakes in finance.
I always am curious. I'm like, why did this person look at my profile? I have no idea. Okay, so what Stripes?
I'm usually refreshing that like every 5 minutes. I just want to know who has viewed my profile recently.
Right. Okay, so the Stripe use case is really cool. So basically what they've addressed is they have dozens of engineering team at Stripe. And they're all working on different problems, with the majority of them focused on real-time data. And then they have to be able to take all this real-time data from all these different engineering teams, be able to bring it into one consolidated view, and then share it amongst all their internal users that then need to be able to access that real-time data. So like it could be I can't even really see like what's labeled in the purple ones, but there's like the accounting, finance, and data science, so like if they have like fraud detection that needs to be like, it needs to know right now, but all this data is coming in from all these different sources, and then the accounting and reporting and all that kind of stuff. So all this stuff has to be fed into real-time analytics on the other side. And this is another use case where they're using this technology. It's not as much for end users, although they do have the need for end users to be able to have a consolidated view of their real-time data also. But I really like this use case because I think it just kind of shows the complexity of being able to bring things in and pull it out. And this is just some of the challenges that Stripe's use case faces, which I kind of mentioned. Working with a financial company, you have to be really spot on. You can't really mess up the data along the way, all right? So even like duplicating data and things like that.
Considered harmful. We should file that under considered harmful.
Right.
Yeah.
Okay. So the properties of real-time analytics systems. So when you're building something that's a real-time analytics type of application or something along those lines, I'm speaking kind of an overarching view. There's 3 things that you kind of need. First is speed of ingestion, right? You have to be able to pull the data in real time. Events happen, it needs to be able to be in your system and ready to be used in milliseconds, right? Like instantaneously. The next one is speed of queries. So part of this process is not just bringing this fresh data in, but you also have to be able to make it queryable and accessible. So you have to be able to pull the data in and make it queryable. And then the third one is you have to be able to do it at scale, right? So you might have, in some cases, hundreds of thousands of queries that are coming in all in the same second. And you need to make sure that you're pulling all this fresh data in and making it accessible with all this dimensionality at scale with hundreds of thousands of queries per second. So it's got to be high throughput with very, very low latency. So overarching, these are the 3 things that you kind of need for a real-time analytics system. I think this next one's you, right?
Yeah.
Okay. So today in the presentation, as Tim mentioned, we're going to be talking a little bit about the fundamentals of how to build a real-time analytics system using these 2 technologies, Apache Pinot and Apache Kafka.
Yes, ma'am. And before we get there, it's worth thinking about the fact that analytics is kind of a crowded space, right? There's a lot. Going back to, you kind of go back to the 90s, we had relational databases. Those are just sort of taken over the world, and people figured out some ways to take data out of the transactional database and squish it around and mush it into other shapes so that we could query it efficiently for reporting purposes. So ETL and data warehousing were born back then. That paradigm held on for 10 or 15 years, and then the so-called big data revolution happened. It always feels a little... So, I would like to bring the term big data back. It's time for a retro, ironic usage of the phrase. So the big data sort of thing happened around 2010, and all of these new solutions appeared on the scene for doing this. And the landscape these days is crowded. There's just a lot of options. And so when I first started looking at Pinot, one of the things I was asking, I was like, well, why this, There's a lot of things to do. And if you look at that basic landscape, there are some non-functional requirements that you're trading off. Okay, it's an engineering problem, and there's trade-offs you have to make for the kind of system that you want to build. And by the way, this is exclusively limited to OLAP things. So OLTP is over there. All those databases are doing their thing, managing transactions. Kafka is managing events. Everything is fine over in the transactional world. This is strictly in the analytics world over to this side. So there's kind of this continuum. You've got what we might call, let's see, do I have, it's going to be too slow. Okay. Let's back up. There we are. These kind of legacy solutions over here, BigQuery, Presto, Spark SQL. It's a little rude to call some of those legacy because they're like massive systems that get used all the time. But they are, we're saying, very high in flexibility. What that means is you throw SQL at them. Okay, whatever it is that you want to do, you write a SQL query and you can do what you want, right? That feels very fluent and very flexible. It's a language we all know. It's super powerful. We can do what we need. However, latency is not that great. Like everything takes 5 seconds. And 5 seconds is amazing if there's a petabyte of data, right? If you've got billions and billions of rows and they're large, that's great. But if you've got 10,000 rows, it still kind of takes 5 seconds to get something done in one of those systems. And like Karin was talking about, she was talking about explicitly user-facing systems. If you are Uber Eats or whatever, pick your meal delivery service that is popular where you live, and you want to know what is the delivery time for the 5 hamburger joints nearest you, you don't want each one of those to take 5 seconds to run, right? You're not going to be on the page for that long. So these things need to be much lower in latency. So they are very high in flexibility, very high in latency, suitable for reporting and dashboarding. That's kind of the world in which they were born. They're designed for that. They work well in that space. And I guess to be clear, this is not me saying Spark SQL and Presto and BigQuery and Snowflake and all these things are somehow bad. Okay, they're not. They're very good. And they're broadly deployed and very successful. But they're focused on a certain set of non-functional requirements. As we come over this way, we have things like Druid and Elasticsearch, certainly lower in latency and also lower in flexibility. And when you try to do user-facing analytics in something like Elasticsearch, you can get super fast document retrieval. It's great at scale, but it's not going to help you with aggregations, for example. You don't just get to throw SQL at it and have it do things for you. You're not going to have as good an experience. If you want really low latency, you can just go build this with a key value store. And in fact, the first use case Karin was talking about, which, if you'll recall, was good. Somebody said it. I was going to make it awkward, but somebody saved the rest of you and said LinkedIn.
I was also questioning it, by the way. I was like, what was
my first use case? So it's cool to talk to the team that did that work, right? Because these are engineers and product managers, and they're trying to build new features into the site. And LinkedIn is like, okay, we have all these people with their resume here, and okay, like, cool, my resume is there, and I've got contacts, and there's people who randomly add me, and I met somebody at a conference 10 years ago, and I don't remember who they are, and why would I go back to this site more than once a month, right, to just check on what unsolicited contact requests I've gotten there. It didn't have a lot of engagement. They're trying to solve this problem. They did that through the things Karin was talking about, like who viewed my profile, absolutely feeds the inner narcissist. Don't deny it, right? That person is in there. You don't like it, but he or she is there. And you just want to know who's looking at my profile. That's a cool feature. That gets people coming back.
Tim refreshes it all the time.
All the time. All the time.
We're not judging. Everyone here relates.
She's judging a little bit. But, and I mean, other things like just the feed. Every time you refresh that feed, it changes because the fact that you viewed a story modifies the weight of that story. And so there's just like all of these kind of interesting queries happening there based on a history of data. These are, properly speaking, OLAP things, and they have to happen in real time. So the latency characteristic now goes from seconds to maybe on the order of 10 milliseconds, something times 10 to the 1 milliseconds. That's kind of the latency characteristic you need. So originally, they built that with a key value store because that's all they had, right? And you can make a key value store go real fast. As long as you don't do something really stupid, right? So they did that, but what is that life going to be like? That life is going to be like you manually pre-calculating a bunch of stuff, And that's life with a key value store, right? If you truly just have things to look up, that's great. But if there are things in the world that are mutating and you're needing to reflect those in the key value store, then you're probably doing a lot of pre-computation and constantly rewriting keys. And you're not living your best life, really, because what are you being in that case? You're kind of being a database. And that's lame work if that's not the job that you signed up for, right? You probably want to be, well, in the case of LinkedIn, a developer building features on a social media site. Or in the case of whatever your job is, you want to be delivering features to whoever your customers are, not being some layer of data infrastructure. So lots to say here. And the point is that these systems over here work very well for the dashboarding and reporting for which they're intended. Their latency characteristics and scale characteristics match that space well. They will continue to be used and continue to be successful. Key value stores are a great thing. They will continue to be used, continue to be successful, but don't build databases out of them. That is a bad life choice. And that's kind of where Pinot enters the world. Anyway, a little bit on... Oh yeah, there's you know you followed along without the dots, right? Okay, a little bit on Kafka. I'm assuming most of you are broadly familiar with Kafka, but we're kind of talking about a Kafka and Pinot integration. You know, I bet I'm not going to call it pacing. I'm going to say my peripatetic style. It's a good vocab word for you, is probably not good for the camera because I just went totally out of where the light was. Anyway, let's talk a little bit about Kafka and how Kafka works. You've got, Kafka is a system for managing events. Events are stored in these things called topics. Events get produced into topics and get stored in order to a first order approximation, right? There's a lot more to say about it than that, but that's basically a topic is a log of events. It's this system of record. Hey, there we are, see? The
really
camera
good
can
job
see me
on-
again.
You're like really challenging the cameraman.
I am.
Like, let me see
I
how
am.
far
This is
out
a
of-
partnership. We're both pushing each other. Helping each other grow. That's kind of what it's all about. All right. Topics can be split into pieces called partitions. Those partitions can be stored on independent servers, independent brokers in the Kafka cluster. So you can scale out a cluster kind of as much as you'd like, or pardon me, scale out a topic basically as much as you'd like. Once you do that, then you got the whole problem of like, how do I know how to write things to a topic? Well, those little events that you're producing, it turns out those are key value pairs. So you can, you figure out ways to assign them to partitions by hashing the key and, all the usual suspects in there. The details of which are not super important. You just need to know that you've got these scalable topics. Specifically on the keys, right. So if you look at the shape of those numbers, I didn't want to write big long keys because they just don't fit in the shapes. It doesn't look nice. But those different shapes would be different key values. And as long as the key is the same, those events are always going to wind up in the same topic. So you have like some concept of ordering, some kind of limited ordering within Kafka at scale. And it's a good deal. You got producers. Producers are applications that write into topics. You got consumers. Consumers are applications that read from topics. So they're scalable in interesting ways. And there's really a lot you can do with just that. There's all kinds of cool systems you can build on Kafka. And Kafka is optimized for telling you what just happened, right? Instead of modeling the world on the basis of what is, Kafka encourages you to think about what just happened or what happens. So it is a fundamentally event-based way of thinking, which is cool and a little bit different. The first event-driven system that you design, you kind of bump into a lot of weird questions and just different ways of thinking about building a system than you're used to, because most of us, the systems we have built, are based on relational databases, schemas, all of which encourage us to think about what is, things in the world, not what happens. Kafka encourages you to think about what happens. So you've got this great system for telling you what just happened, but if you want to know what is true over the context of some time, like what's a roll-up of state right now, that's a not obvious question to answer from a Kafka perspective. There are a number of point solutions that are cropping up in that world. Well, cropping up, I mean, Kafka Streams is 5 years old, six years old now. So it's hardly new. You can, using a Java API called Kafka Streams, you can materialize kind of a tabular view of a summary of what has been true over a topic, over the events in a topic over a long period of time. And that's super handy if you're writing Java, which in this room is probably not that controversial of a suggestion. And you only get one index. Remember how I said that the events are key value pairs? Well, that key is your index. So you can index on anything you want as long as it's the key. And that's not very exciting. You have other solutions in the world like KSQLDB, a thing that Confluent makes that is a SQL version of the same thing. It's like Kafka Streams, but in SQL. And so now I can define SQL queries that will roll up status or roll up something like analytic queries over a topic over time. But again, I'm limited my ability to index there. Now, there's more to say on both those. Maybe we can come back to them later. But there are these ways of doing things within the Kafka ecosystem that help us see what's true now over time. But there isn't a single kind of good, versatile piece of infrastructure we can plop down strictly within the Kafka ecosystem that makes that happen. The Kafka plus Pinot thing, though, is super cool. Karin, I forget who's talking about this slide. Is that you or me?
I can talk about it.
Why don't you talk about this slide and tell me when to advance and I'll
I get
advance.
excited about Pinot, so I'll
You
talk
should
about
get
it.
Karin gets very excited about Pinot, and I want
He
to make
gets
sure
excited about Pinot too, but not
we
like I
bounce
get
back and
excited
forth.
about Pinot.
All right.
All right, so I'll give you guys a little bit of like what is Apache Pinot. So Apache Pinot, by definition, is a distributed OLAP data store for high throughput, low latency queries. Basically, what its capabilities are is it has the ability to ingest data from a variety of different sources, and it could have streaming, like things like Kafka, or batch, like things like Hadoop or S3 or whatever, and you can pull all this data in from all these different sources, and it has ability to do pre-aggregation, like it merges into one consolidated view. The pre-aggregation with very high dimensionality, and also makes it available for querying at very high throughput for a lot of queries coming in at the exact same time. I'm trying to think about like what else was something in the definition, but like it was built originally at LinkedIn, similar to Kafka actually, if you guys know the history of Kafka. Kafka was also originally built at LinkedIn. And yeah, did I cover the definition okay?
No, I think it's great. I think
Okay.
it's great. Yeah, all
You guys
kinds of great
understand?
things come from LinkedIn. This is the second. I've never worked for LinkedIn, but this is the second company in a row that I've worked for that is based around a piece of data infrastructure extracted from LinkedIn. So
Yeah.
this is working really well for me so far. I love it.
I mean, they have a lot of data problems, so it works out.
Right.
So I'll also talk about this, and then he'll get into the
got it.
architecture a little bit about what's under the hood in Apache Pinot. So Apache Pinot, I think it was something like 8 years ago or something when they started developing this, but over time it has been very widely adopted. It's a very mature product now. Over 100 plus companies are using it. Our community is growing pretty rapidly. Like, I don't even know if that number is actually accurate now. But our community is growing just very, very fast. We have a Slack if you guys want to join it.
Hang on a second.
And
Let's do better than that. We have a Slack. Join it. Go on.
oh, nice. I like that. See, Tim's coming in all the right moments. And also in terms of performance, this is actually taken from the LinkedIn use case. This is like the best, I think, Apache Pinot recorded, like at least one that's like actually recorded in terms of performance. At LinkedIn, they have about 1 million events ingested per second with 200,000 queries, like end user queries per second with sub-second query latency, which is pretty powerful considering all this dimensionality and things like that, which is like where Pinot is really powerful in, is this indexing capability, which Tim will review afterwards. But I think now I hand it over to you.
Within mere minutes. Yeah, and again, the key differentiator is really query latency. I mean, there are lots of databases that'll handle large amounts of data. That's cool. That's been true for a long time. But trying to get queries into the order of 10 milliseconds response time for certain kinds of optimized queries. You can make things that take longer. Obviously, it's SQL. You can cause all kinds of damage. That's the differentiator. And the Slack workspace is a great thing if you want to get started. It's a great place to go get questions answered. Let's talk about the architecture. Now, We're going to start with, so imagine there's this Kafka over here, and like Karin just said, it doesn't need to be just real-time input. Okay, there are, we have the ability to do batch imports also, because it's an OLAP database. So there might be just massive, we'll say steaming piles of Parquet files in S3 or something like that, and you might just need to get them into your super fast OLAP database. And so there is a batch import process for creating what are called segments on these servers. Segments are where table data lives. And by the way, I don't know if we explicitly said this, but by implication, the data model is tabular. I mean, it's SQL, so it just looks like tables, and everything looks super familiar. So anyway, these segments that are stored on these Pinot servers, that's where the data lives. You can do this batch import process, or you can do streaming input, streaming ingest into what are called real-time segments.
And the combination of both is really powerful.
Yeah.
Consolidated view of batch and streaming.
Yes, exactly. And be able to do one query that just gets at all that stuff. There's a component called the controller. There's a Zookeeper instance, because there's always a Zookeeper instance pretty much that maintains the mapping. Well, it maintains a lot of things, but among other things, the mapping of these segments to the servers they are currently living on, and the mapping of tables to segments. So the table is the abstraction that you're working with. That's broken down into a number of segments. Those segments are just that stuff actually stored on disk. And Pinot is a column database, so the actual format of the data on disk is this sort of run length columnar encoding of things, which is just typical of OLAP databases. And so, we've got the actual segments stored on what are called the servers. And that is actually, you're like, aren't they all servers? Look, we're making the rules here. And we call those boxes the servers, as distinguished from the brokers. So servers and brokers are both things that there are potentially lots and lots of in a Pinot cluster. The brokers are the things
You
to
might
which...
have to click one more to get the broker.
Oh,
There you
hey.
go.
Look at that.
That's the broker.
Like I was saying, thank you. There are potentially lots of, in practice, always lots of brokers. Brokers are the machines to which, or the processes to which, queries are addressed. And then the broker figures out, okay, what servers do I have to scatter those queries to? That is, where are
Click
the
again.
segments? What's that?
Click again.
Look at that. Look at that. What servers do I have to scatter those queries
I
to?
helped him. That's how it works.
They execute on the servers, and they're gathered back, and you get them back. So it's a unsurprising kind of scatter-gather way of doing this, and there you are.
Yeah, so the brokers are just communicating directly with the client.
Yeah.
Client queries come in, go to the broker, they go out, scatter, gather, bring it back in a merged consolidated view, and then hand it back over to the client.
And we are going to skip to indexes. So,
Fun.
I mean,
This is cool.
the mechanics of how am I deciding to be a distributed database are interesting. Like, okay, we have this thing called segments. It's just a way of partitioning a table, right? You have big giant tables, and you got to put them over lots of computers, and we call them segments. And here's how we manage segments, right? That's all cool, and that's something that you're going to do if you're going to be a distributed database. But I think your money is made in indexing. You need to be able to read things in interesting ways, and so the differentiator is indexing. And in Pinot, indexes are pluggable. So there's a kind of a cool set of about a dozen of them right now, and that's going to be a growing number as time goes on. I think a lot of the low-hanging fruit kind of cases of the sorts of reads that we want to do already exist, but there will never stop being new Pinot indexes. And I think when the histories are written, will there be a history written? I mean, I hope so. But when they're written, I think the decision to make indexes pluggable is going to turn out to be a very consequential one in the life of Pinot as it grows. Anyway, some of the kinds of indexes are listed here. The ones that really stick out in my mind are geospatial index. That's important. And if you look at use cases we've talked about, like Uber Eats, I mean, that's a fundamentally geospatial kind of thing. So that index is there and robust, and I think chiefly maintained by the set of committers that come from Uber. There's a JSON index, so you can index arbitrarily nested JSON in an efficient way, in a fairly intuitive way. So ingest JSON and query it in a way that is not painful and doesn't make you want to hurt yourself. Text indexes, that's just embedded Apache Lucene. So if you know Lucene, the kinds of things you can do there. You can do regular expression searches. You can do fuzzy text searches, all that sort of stuff. If you've got an unstructured text field, you've got that working for you. There's an inverted index for kind of keyword or term searching. And the big one is the StarTree index. Now,
Do you want to go to the slide?
we have a slide.
We do.
Inverted index, you know an inverted sorted index. There's a sorted index. Okay.
There's a StarTree index.
Here's a StarTree index.
Notice that we work for a company called StarTree.
So now you know the name of the company that employs Karin and me is an implementation detail that has leaked into the interface. It happens all the time. Don't act like you've never done it. So here we are. Yeah, StarTree is, I mean, it's a fun company name anyway.
Yeah, it's also like the people who authored the project. They're like the creators of it. So it's like, it's okay for them to take the,
Exactly.
This is the most powerful indexing, I think.
And I think the name is just kind of cool and evocative anyway.
It is.
Even
It
if,
is cool.
But the thing is, like, what if 5 years from now, there's another better kind of index and like nobody cares about the StarTree index anymore? Here's the thing. It doesn't matter because it's a cool name. It's fine. So sometimes when these implementation details leak, it's like not the worst thing in the world.
We
so
have 5 minutes.
Oh, I know. We're fine. This is really this is
It is good.
This is the money. It's basically like writing persisting a pivot table to disk is how this works. So you've got dimensions that you define and an aggregation that you're defining on those dimensions, and those aggregates are stored in the nodes, in the leaves of the tree. So you get log n access to your search terms in the tree, and then the aggregation you want is right there. So the benchmarks appear magical when you look at what it takes to satisfy these queries without this index. And these are very typical, again, relatively highly dimensional, simple aggregations. It's a thing you do to an OLAP database a billion times a day. When you look at the benchmarks before and after the existence of the StarTree index, it looks like something's broken and you can't be measuring this right. It's just too fast, that kind of thing. So there are good benchmark results that come from this.
Yeah, definitely.
All right, now we are not going to look at that.
Take a note, though this is cool. Yeah, so just basically to sum it up, this is a good combination for pretty much any user-facing real-time analytics use case that you have. This combo.
And we've given you some use cases, like we're talking about LinkedIn and we're talking about Uber Eats and Stripe, and there are like a lot of retailers. It seems like a lot of retailers and financial services companies. As I look at open source users and like actual our company's customers and all that kind of stuff, it seems like a lot of them are becoming interested. This is a new thing, though. I mean, I think that's what I want you to take away. I want you to take away it's a slightly different category of OLAP database, optimized for high-speed ingest, optimized for very low latency queries. The received tradition of, we'll call them the big data OLAP databases, handle large amounts of data, generally kind of a batch ingest, kind of bolting on streaming ingest features as the world becomes more and more event-driven. But they're all optimized for a dashboard or for a report, for the everything takes 5 seconds, right? In Pinot, everything has to take 50 milliseconds or 20 milliseconds or something like that. That's the key non-functional requirement that really sets this thing apart. And why? Well, it emerged in places where analytics queries had to be exposed to users. The problem of taking, we'll just say, the data of the business and exposing it to decision makers in the business is an ongoing problem. We always have to evolve that tool set and get better and better. But to some degree, a little bit of yawn, right? That's a thing that we know how to do. What we don't know how to do is take that data and expose it to the people who use the service or the system or the app or the site or whatever it is you do. Whatever line of work you're in, whatever kind of customer you're serving, there hasn't really been a tool set that's good at ad hoc analytics queries with a latency characteristic that you can use to expose to users. And this is kind of a sea change sort of thing. It's a different set of features that honestly most of us have not been thinking about. We tend to think about analytics as a thing that satisfies a report, not a thing that powers a user interface feature. And I want you to let that sink in and think that there are ways to take, as I say, the business, the data of the business, and push that out to the people who are using the features you're building. That kind of draws them now into the community of decision makers, not just people with important titles and nicer clothing and not always a t-shirt and however executives dress. Like I usually wear a t-shirt.
So judgmental.
I know, right? I feel like I have buttons on my shirt. This is a little bit losing street cred here. But now the people using your system are included in the community of decision makers. It's a pretty radical step, right? If you think about it, that's a big deal. This is a new tool. There aren't a lot of things like it that exist in the marketplace of open source options. And I think we'd like you to go away and to have that be the thing you think about. This is a new kind of thing you can build.
Yeah, the actionable insights. And
yeah. And everybody wants to be a disruptor. Everybody wants to be a category creator, right? I mean, these are sort of tired words. I'm not going to say disruptor. I am going to say a little bit of new category, though. I think that's how you should think about it.
Yeah. I mean, it's definitely transformed things.
So, with that.
If you liked it, please tweet about it with the Twitter handle for Vox Days Zurich. It's on your thing.
Yes. And you can mention us, and you can go to dev.startree.ai. There's an ever-growing amount of resources there. You can learn more about Pinot, learn more about real-time analytics.
You can also join the Slack and just ask a bunch of questions.
You can join the Slack. Mm-hmm. And we thank you for being
Wait, no. You should join the Slack.
There you go. And thanks for coming. Really appreciate it. Hope to talk to you later.
I also have StarTree stickers/business cards. They're a sticker business card.
Yes, come get these.
You guys
these are
want
good.
stickers, you guys can come get them.
Well,
Okay.
thank you so much, Karin and Tim. And do we have any questions in the audience? It's hard to see with this.
Oh, I was going to say, we
Yeah, I
covered
know,
everything.
right?
No one has any questions.
No way you could have a question, sir.
Does he want?
Yeah.
So you solved it very well, and it's very fast. It's great. Can I get rid of my Redshift and Spark and all these things, or
Maybe.
things you cannot
I mean, that's a big question, right? And the way Pinot presents itself to you is the user-facing real-time stuff, right? Because that's what it's built for. And like I was fairly explicit saying, all those other things that are doing what they do now, they may be fine, right? Of course, having said that, could you also build dashboarding and, well, it's arbitrary SQL, right? So the current subset of the SQL language that Pinot supports is smaller than, say, what Presto or Trino or Spark SQL supports. That's a moving target. You know, that subset is getting larger and larger. So can you? Maybe. I don't know. Maybe not yet. Probably at some point, yeah. I don't see why it doesn't want to take over that whole workload.
Yeah, I guess probably it also depends on what you're doing, right?
Yeah, I mean, it's going to depend, but it's probably going to come down to how many joins you're doing right now and what joins features are supported in Pinot today. That's going to be different a year from now. All that stuff's being actively worked on. And probably someday the answer will be yes, do that. But not saying that yet.
Yeah, so maybe you answered part of the question. We are having currently a system with around 700 relational tables, which is fed by files during the day, and in the night we run queries on it. And we want to go change this to have Kafka queries feeding the system. Would Pinot be able to replace this database, or do you think it's not yet powerful enough? Or
again, at the level that we're able to talk right now, the most interesting limitation is going to be what kind of joins you do. And that's a moving target inside Pinot, right? Because there's limited join support, and that's getting to be a lot less limited as time goes on. So you might need to look into the details, because you know what you do with those tables.
I guess it's a limiting factor since we have like, I don't know, maybe 1,000 different SQL queries up to several hundreds of lines, and yeah.
My guess is there's one or two joins in there. Yeah. So maybe not. A year from now, different answer.
Okay, thanks.
You bet. All right, I think we're out of time. Andres, you're the boss, though.
No, you guys are the boss, and you guys are also the boss. I'm just here handing the mic. I think we're out of time, but if there's any other question, you can still talk to Karin and Tim outside of the room. So thank you so much.
Have a good one, guys.